Hello, this is Mrs. Bada, and I'm here to do a little review with you on how to rewrite your quadratic equations so that they are in standard form so that you can factor them in order to solve them for their solutions. So, of this worksheet, you have 8 problems. I am going to guide you through 5 of those 8 problems. And so you can do them along with me, and then you will need to complete the other 3 on your own. So let's get started with number 1. Remember, in order to be in standard form, we need to have our x squared term with a coefficient of a, we call it a, then our x term, and we call whatever that coefficient would be b, plus our constant, so that's your number without a variable, set equal to 0. Now, if it ends up looking like this, where you have each of those terms, you have your x squared, your x, and your no x term, I call that, that's a trinomial, and you're going to look mostly to solve that by setting up into 2 binomials. Now, sometimes you will always have, well, first I'm going to start by saying this. You will always have x squared. That's what makes it a quadratic. So that will always be there. Sometimes you'll have x squared, x, and no x. Sometimes you'll be missing the x term. And it would just be x squared term plus your no x term or your constant. Okay? Sometimes we might be missing our constant term. And so your equation would be set up like this. X squared plus x equals 0. No constant, no x. Or you could possibly be missing both the x and the no x term, and just your x squared equal to 0. Regardless of how your quadratic equation looks, all of the quadratics we've seen so far we can solve by factoring. So let's jump into a couple of examples here. What is the first step to get this example, x squared minus 6x equals 7, into standard form? If you're thinking subtract 7 on both sides, you're correct. And when I write it in my standard form, x squared term, x term, no x term, we get x squared minus 6x minus 7 equals 0. Go ahead and factor that. You should get x minus 7 times x plus 1 equals 0. Now, the order doesn't matter. If you had x plus 7 times x plus 1 times x minus 7, that's okay. And the reason for that is because we know we could swap those two if we wanted, because multiplication is commutative. Now, we have x minus 7 and x plus 1 because negative 7 times a positive 1 gives us a negative 7, and negative 7 plus a positive 1 gives us that middle term of negative 6. Next, we're going to solve. Set each factor equal to 0. Solve each of those little equations that you get. Add 7 on both sides here. Subtract 1 on both sides here. And we can box those answers, that's fine, but a nice way of recording your answers when you're solving quadratics is to put them in curly brackets. They're your solution set, 7 and negative 1. Again, if that order was switched, and you had negative 1, 7, that's fine. They're just both solutions that will work for x. 7 squared minus 6 times 7 is equal to 7. Negative 1 squared minus 6 times negative 1 is equal to 7. If what I just did verbally, if you were to do that, you plug the x values in for x, you will get a true statement because they are solutions. Moving on to number 2. go ahead. Think about what your first step would be to get this in standard form and what it would look like when written in standard form. Great. Now, in this case, we're subtracting the 12x, but we want to make sure we put it in the right spot. That x term goes in the middle there. This way it's set up in standard form, so it's a nice trinomial that you can now go ahead and factor. What two binomials will multiply back to give us x squared minus 12x plus 32? X minus 8 times x minus 4. Or the other way around, x minus 4 times x minus 8. Negative 8 times negative 4 gives us positive 32. And negative 8 plus negative 4 gives us negative 12. Now go ahead and solve and write your solutions as a solution set. Set x minus 8 equal to 0. Add 8 on both sides to get x equals 8. Set x minus 4 equal to 0. Add 4 on both sides to get x equals 4. Your solution is 8 and 4. All right, number 3. Go ahead, get that in standard form. You subtract that 3, move it over to where everybody else is, and we've got 5x squared plus 2x minus 3 equals 0. All right. Now, we need to find our two binomials that are going to multiply to give us that trinomial. And this is a nice example, even though, yes, we don't love ones that have a leading coefficient that's not 1, because it makes it a little trickier. But 5x squared, the only way we can get a 5x squared by multiplying is with a 5x and an x. So we know what that is guaranteed. And we don't have very many options for multiplying to get a negative 3. So you can just do a few quick little guesses and checks, right? What if I put negative 3 here and a positive 1 here? Because negative 3 times positive 1 gives me that negative 3. When I do this, negative 3x multiply negative 3 times x and my 5x times my 1, and I add to see what that middle term would end up to be, I do get that middle term. So my first guess was right. Now we just go ahead and solve. Set this equal to 0, 5x minus 3 equals 0. Set this little equation equal to 0, x plus 1 equals 0. All right, over here with that 5x minus 3 equals 0, we're going to add 3. We get 5x equals 3, and then we divide by 5. And we just leave it, x equals 3/5. Your best bet is always leaving your solutions as fractions, because if you change it to a decimal and you get a value that you have to round, then it's not an exact solution. So I think it's great to keep it as a fraction. We're not scared of fractions. All right, and then over here, I subtract 1 with my x plus 1 equals 0, and I get x equals negative 1. In my curly brackets, 3/5, negative 1. And it doesn't matter. You could write negative 1, 3/5. That last bracket was looking kind of weak there. All right, 2 more I'm going to do with you. Examples like 6, students tend to, I find, overcomplicate when they're really easier than they seem. All right, so go ahead, get it in standard form. What you should have is 5x squared minus 15x equals 0. Now, how do we factor this? It is not a trinomial, so I'm not going to factor it into 2 binomials. So my only 2 options are difference of perfect squares or GPS. Which do you think it is? If you chose GCF, you're right. The reason why is, although, yes, it's a binomial with subtraction, it's difference, we don't have perfect squares here. The 5 is not a perfect squared. The perfect square, the 15 is not a perfect square, and the x is not a perfect square. Remember, perfect squares are when we square our integers. So 1 squared is 1, 2 squared 4, 9, 16, 25, etc. And when you have variables, it's variables with even exponents. So, well, what does that leave us with? Like I said, GCF. And what is the GCF for this binomial? What is the largest term that we could divide into 5x squared and 15x? It's 5x. If I divide 5x squared by 5x, I'm left with x. And if I divide this negative 15x by 5x, my x divided by x gives me 1. 5 divided by 5 gives me that negative 3. And now I'm just going to break these guys up and solve them. Sometimes I like to use arrows. Sometimes I just write them down, these little equations that we create after we find our factors. All right, 5x equals 0. Well, we got to divide by 5 here technically to figure this out, but x equals 0, and that is a solution. We don't just leave that off. That means if you substitute 0 in, you get a true statement to your original equation. And then over here with x minus 3 equals 0, I'm going to add 3 on both sides, and I get x equals 3. So my solution set here is 0, 3. All right, and last one, a quick little easy one. Try that on your own real quick. When you move your 16 over, we should get x squared minus 16 equals 0. And you should have recognized that this is difference of two perfect squares. And so we take the square root of x squared is x. That goes in the first spots. And the square root of 16 is 4. And that goes in the second spots. And 1 is a plus and 1 is a minus. And then we set these equal to 0 and solve. So your solutions here are negative 4 and 4. Okay, hopefully this video was helpful, and your job is to do numbers 3, 5, and 8 on your own. Have a great day.